Hello guys, so today we are going to talk about graphing inequalities. It's the last thing I want to talk about in our unit, going over a correlation of data and how to find a fit for that data and a line that matches that data, and then graphing those lines, graphing systems of equations, and now graphing inequalities. So when we're graphing systems of equations, it's multiple linear equations on the same coordinate plane. And those are equations that have an equal sign in them. But that's what makes them an equation. Graphing an inequality is when we don't have an equal sign, but we have a greater than, a less than, or greater than or equal to symbol. So it's going to make our graph a little bit different when we go to graph it on the coordinate plane. And there's a couple different rules that we have. Very similar to when we were solving equations, we could move across the equal sign, we could move letters and variables. But when we solved inequalities, certain movements or operations flipped our inequality signs and changed things around. So very similar to when we solved them, when we graphed them, there's a few different rules. So we're going to go over that today as we introduce that. It's nothing too crazy different than what we've been doing. It's just a few new rules. So this will be page 70. We're going to flip to that now. Okay, so here on this page, this is page 70 of our notebook. We're going to title it Graphing Inequalities. I'm going to write some information up here, and then I've glued in the 4 graphs that were posted as your attachment for today in Google Classroom. And I'm going to show you examples of how to graph inequalities. And these are super simple, just either horizontal or vertical lines. So we're not even going to get into linear equations yet. I just want to look at just x equals a number or y and then a number. So let's look at our rules. So you have x lines, and then you also have y lines. Okay, and this is exactly like when we were plotting points. If you're plotting a point and I say x equals 2, and you go to 2 on the x-axis, you're going to draw a line up and down over 2 so that it's cutting through the x-axis. And so anything that's on the x-axis is going to be a vertical line because it has to cut through the x-axis. Even though the x-axis is your horizontal axis, all of the vertical lines are x values on that line. So if I look down here, you guys see how the x-axis right here is this horizontal line right here? Well, every single one of these vertical lines is an x value. This is x is 1. This is x is 2. This is x is 3. So every single vertical line is an x value stemming from that axis up and down. And then since the y-axis cuts right here, every single one of these horizontal lines is a y value. So when y is 1, all the way over to the left and the right, that is where y is 1. So the numbers actually cut through differently than the axis itself. So x values will actually be vertical lines. Your signs that you have, so if it is less than or equal, you're going to shade to the left. So the difference now, instead of just graphing a line, we're shading because it's not equal to a number. It's either less than or equal to. So we're going to start shading. If you have a greater than symbol or a greater than or equal to symbol, you shade right. You kind of shade in the direction that the arrow points. So this arrow is pointing to the left, so we shade left. This arrow is pointing to the right, you shade right. If we look at y values, so like I just showed you on the y-axis, any y value is going to be a horizontal line because it's going to cut through the y-axis. Even though the y-axis is up and down, the actual y values go the other way. Same rules. If it's less than or equal to, you're going to shade below because again, y is up and down. If it's greater than or equal to, you shade above. And then the two super big rules, don't forget these. If it's just less than or just greater than, those are dotted lines. So I'm going to show you in a second. We're going to do some examples. If it is less than or equal to or greater than or equal to, that is a solid line. And how I remember is it has the solid line underneath the symbol, which means when I graph it, it's going to have a solid line. So let's do 4 examples. Again, these are going to be easy. Let's look at x is less than or equal to 7. Okay, so you need to go to the x-axis and find 7, which is right here. 1, 2, 3, 4, 5, 6, 7. Right there. Okay, so at 7, because it is less than or equal to, I'm going to have a solid line right here at 7. So I'm going to go all the way up and down this 7. Right there. Now, look at which way my symbol is pointing. It's pointing to the left because that is a less than symbol. So if I look up here, we did make a vertical line at the value. If it is pointing this way, we shade left is what it looks like. So all of this gets shaded. I will advise to shade with lines because when we get into graphing multiple inequalities on a coordinate plane, if you graph with lines that kind of go in different directions, you'll be able to easily see where they overlap. It'll look like, it won't look crazy if you're just like coloring everything in. That's just a bit much. So we shaded everything to the left of our line because of the way that the arrow is pointing, and we made our line solid because we have a solid line underneath it. Now, what if we had y is greater than 2? Well, on my y-axis, I would go to 2, which is right here. And because it is a greater than symbol, and it doesn't have an equal than underneath it, it's just greater than, it's a dotted line. So before you go drawing a line, you need to look and see what your symbol has. Is there a line under your symbol? No. So don't make a line. So at 2, I'm going to make a dotted line. And then my arrow is pointing to the right. So that follows this rule. I'm going to shade above. So when I shade, I'm shading everything above. And again, I advise shading with lines, because if you try to just color the whole section, when you start doing multiple inequalities, it's going to look like a mess. So just choose lines that go in one direction for one and in another direction for the other. Now, what if we have y is less than or equal to 3? Okay, so now for this one, we're going to go to the y-axis and find 3, which is right here. My symbol has a line underneath it, which means I do get to draw a solid line at that value. Otherwise, you would not. And then because it's less than, look up here for y values. Less than means I shade below. And again, just find the symbol that you have. So I'm going to shade everything below. In straight lines. This is the longest part of inequalities, is the shading. And then the last one, let's say I give you x is greater than or equal to 5. No. Let's just say x is greater than 5. No equal then. So on the x-axis, you're going to find 5. So this is my x-axis, so 5 is right here. And then if I look at that symbol, there's no line underneath it, so I cannot draw a solid line. So I draw a dotted line. At that value. And then I shade to the right because the arrow is pointing to the right. For the x's, it's a lot easier because you can shade in the direction that the arrow is actually pointing, because your x-axis runs like the ground, so these arrows make more sense. So I would shade everything to the right. Just like that. And that is how you graph inequalities. So when we graph equations, it's just a line either at that value, or if it's a linear equation, it's starting at that y-intercept following a specific slope, but it's just a line. Graphing inequalities, you start at that point and you shade based on the information given to you with your symbol. So when we get into graphing linear inequalities, you'll recognize those lines and those slopes and those y-intercepts, but you'll either have a dotted or a whole line when you graph it, and you will shade based on the symbol that's given. There won't be equal signs anymore. It won't be y equals mx plus b. It'll be y is greater than or equal to or less than or equal to mx plus b. So knowing where we shade and how we shade is important. Real quick, you're going to flip over to the next page, which is page 71. And I'm going to give you one example of how we would, now that we know how to shade and which way the arrows tell us to go, how we would graph an inequality. We're just going to do one example together. So flip over real quick and title this page. We'll do this together while you're here. Oops, sorry about the lights. Graph to solve systems of inequalities. Step number 1, and this is just a handwritten page. You will need one graph on the bottom of this page. So if you want to print 2 copies of the worksheet that I attached for today, that way you'll have a set for the first page and a set for this page. And as always, if you need to pause for a second and go print or go find you another graph, feel free. The first step, graph the inequality. Include the shaded areas. That's important. And we just practiced how we graph and how we shade. So don't forget, I'm going to put right here as a reminder, remember dotted or solid. Your lines can be either or. This isn't just a solid line when we graph a linear equation, because these are inequalities. The second step, once you've graphed them, you're going to find the intersection of the shaded areas. So you guys remember when we graphed linear equations before, we found where the 2 lines crossed, and that point that they met was the answer. Well, now the place where the 2 shaded areas overlap is the answer. So I'm going to put right here, solution is in overlapping shaded areas. So any value that's in that shaded area is a solution. And that's all that there is to graphing systems of equations. So I'm going to give you an example now. Y is greater than negative x minus 2, and y is less than or equal to 3x plus 6. So, in looking at this, we know that there's an imaginary or an invisible 1 right there. So that's my slope, and that's my y-intercept. That's my slope, and that's my y-intercept. So I know it's in slope-intercept form. So all we're going to do is graph these two. So at this point, I want you to put a graph on this paper. You can draw one. You can glue an extra one down, but we're going to graph these now. So I'm going to glue one of these down and then graph it. Okay, magic. It's glued down. Let's look at our equations. I'm going to make one pink and one green. Those are pretty contrasting colors. The first one is y is greater than negative x minus 2. So I'm going to start at minus 2. That's how we always graph linear problems or linear functions. We start at the y-intercept. So I'm going to go down at negative 2 on the y-axis and put a circle, or a dot, excuse me. And my slope is negative 1. So I would go down and over, down and over. down and over, down and over. Now, if I look at my symbol here, that is a greater than symbol. So since there's no line underneath this, I do not get to make this a solid line. I have to make it a dotted line. So I'm just going to keep putting my dots here. I'm also going to follow this up in the other direction. And now I need to make this a dotted line. So I'm just going to kind of make an extension that goes through each dot, make a line, but I'm not going to connect the dots. So I'm just kind of putting lines through my dots, and I'm not making a solid straight line. So now we have a dotted line. So this is at that y-intercept with that slope. And based on the symbol we've made it a dotted line. Now I need to shade. Remember, step one, graph it and include the shaded areas. Remember, dotted or solid, so we did that. Because this is greater than, I'm going to shade to the right and up, right? Because if this is my line, everything above or to the right would be greater than, and everything below or to the left would be less than. We learned that on the page before. So I'm going to shade everything over here. So again, I like to have lines going in one direction for one of them, and then going in the other direction for the other one, so I can clearly see where they overlap. I highly advise lines and not just shading all crazy. This will make it easier for you to see where they overlap, and it'll make it look a lot neater. Now, I need to graph the other one. So the other one starts at +6 on the y-axis. So I'm going to put a dot there. And my slope is 3. So I'm going to go up 3 over 1. I can only do that one time. So I know that a positive and a positive is the same thing as two negatives. So if I go down and to the left, it's going to give me the same slope. So since I can't go up and to the right, I'm going to go down and to the left. So I'm going to go down 3 over 1. Instead of up 3 over 1, I'm going to go down 3 over 1. Because I didn't have any more room to keep doing that in the other direction. And now I need to connect these dots. And if I look at my symbol, it's less than or equal to. Since I have an equal to symbol there, I can make a solid line. So I'm going to do that at this time. Connect all my dots with a solid line. I should have put the arrows. Connect them with a solid line. And then I need to shade, it looks like everything less than that line. So everything less than that line would be everything that's underneath that line, which I know can be confusing because everything in our body wants to say, well, all of this space over here is like negative. But if we read graphs from left to right, this is where this line starts and the line goes up. It has a positive slope. So if the line starts here, no matter if it's positive or negative, if you're shading over here, you're actually shading on the top of the line. Like this is above the line and this is below the line. Okay, because we're reading from here, we're reading from the left to the right. So this is actually what's underneath that line. If it was like this, that would be very easy for us to say, oh, this is everything less than, and this is everything higher than it. But it's a very, very steep positive slope. So just don't let that confuse you about where we're shading less than or greater than. So we're going to shade everything underneath this line, which is going to be everything down here. And when I shade it this way, I'm going to actually make my lines go the other direction. So since these went up, these are going to go this way. And now you can easily see where they overlap. It looks like perfect squares. And only where they overlap is where the solutions are. So once you've got your graph made, I'm going to give you two examples. Okay, so now that we've shaded both areas, everything that's less than that and everything that's greater than that is 2, -8 a solution. Well, go to 2, -8. Over 2, down 8. Is that a solution? Is it in the double shaded areas? No, it's not. It's in the blue area, but it's not in the blue and pink area. Is 6, 3 a solution? Well, let's find 6, 3. Yes, this is in the pink and the blue area. So your solutions are any values that are in this area that's shaded with both values, or an area where both equations have points and numbers. It's just like systems of equations, but instead of equations only having one possible answer where they meet right here, or a bunch of solutions if they're overlapping, with inequalities, all the shaded area is everything that's included, because we're not just saying it's equal to, we're saying it's everything that's greater than that line, everything less than or equal to that line, which leaves a lot of values to be kind of in the game. That's it for your notes today. You don't have any practice because that was a 20-minute video in itself. So make sure you got all of that down. If you need to go back for anything, you can. If you needed to pause at any moment, you always know that you can, but make sure you have that, because next week we're going to practice everything, put it all together, and then test, because we have learned everything for this unit. So good job, guys.